Hi everybody, happy Pi Day and welcome back to the Feynman technique. Today I have an appropriate integral for you. You'll see why at the end. But anyway, this is the integral. I don't want to say it out loud because it's a mouthful, but just take a look at it and you can see what it is. So, all right, let's get started. Our first step is going to be to create a function of t that you can see it kind of resembles our original integral. Um, it's just, it's just one of these parts here. It's just like it resembles either the numerator or the denominator in our natural log. And I did that because we can express our original integral just by taking f at 1 and then subtracting f at -1. And using the properties of logarithms, those would combine to recover our original integral there. All right, so next, as is standard in Feynman integration, we're going to differentiate our f of t with respect to t by using the Leibniz rule for differentiation under the integral sign, which says that we can take the derivative of this thing right here with respect to t just by taking the partial with respect to t of the integrand and leaving the rest alone. All right. So if we take the partial with respect to t of our integrand right here, we would get 1 over 1 plus t cosine x. That's right there. Then times the derivative with respect to t of t cosine x, which would just be cosine x, canceling this. So now we have f prime of t equaling this. Next, we're going to use a formula that I derived in a previous video. I will link to that video in the description, but it says that the integral from 0 to pi of 1 over a plus b cosine x is equal to pi over the square root of a squared minus b squared for a greater than the absolute value of b. Of course, we would need that for this to make sense right here. We need a to be greater than the absolute value of b. All right. So plugging in a is equal to 1 and b is equal to t into our formula here, we get f prime of t is equal to pi over the square root of 1 minus t squared for absolute value of t less than 1. All right. Next, we integrate our f prime of t to get back to f of t. This is a fairly standard integral. This is just this right here is the derivative of arc sine, so its antiderivative is arc sine. So f of t is equal to pi arc sine t plus c. And then we can use the fact that f of 0 is equal to 0 to figure out that c is equal to 0. So now, oops. So now we have, sorry about that. Now we have f is equal to arc sine t. Now we just have to plug in 1 and -1 and subtract them and we're done. So I is equal to f of 1 minus f of -1, which is pi arc sine 1 minus pi arc sine -1. Of course, arc sine 1 is just pi over 2, and arc sine -1 is negative pi over 2. Adding those two things together, and we get pi squared. So that's why it was appropriate for Pi Day. So anyway, the integral from 0 to pi of natural log of quantity 1 plus cosine x over 1 minus cosine x divided by cosine x dx is equal to pi squared. All right, happy Pi Day again, and thanks for watching. We will see you next time.